The RDA metadata interest group, working together with the other metadata groups, had come up with a set of principles which were presented and agreed at the Amsterdam plenary, so a long time ago. And these are the basic principles. You can also find these on the metadata interest group page if you'd like to go through them. The key points is the only difference between metadata and data is mode of use. Metadata is used for all sorts of things. Metadata is not just for description and discovery. You use it for lots of other things, especially contextualization, i.e. making sure the asset being described is what you need. Metadata needs to be machine understandable for autonomicity, and there are other kinds of metadata that are also relevant, for example, things to do with management of research, such as a research proposal, project information, research outputs, and all the rest of it. FAIR principles, I don't think this audience need to be told what they are. Basically, the F group for finding, the A group for accessing, the I group for interoperating, and one important one here is I3, which includes the concept of qualified references. That means a link between, for example, metadata and an asset described by the metadata must be a qualified reference. That implies semantics, and that may well be represented by a triple, e.g. the metadata linked to the data set or any other asset having a logic statement. And then the R set, the reusable set, which depend to a very large extent on all the others. So a long time ago in RDA, the metadata interest group with the other metadata groups, and indeed from time to time various different domain groups, i.e. subject domain groups, have discussed the concept of suggesting a set of elements that could be used as a reference set, which could be a canonical model to which other metadata standards could be converted. Basically, if we're going to interoperate, we have to be able to crosswalk between one metadata standard and another. If you crosswalk every metadata standard to every other metadata standard, you have an n times n minus 1 problem of converters. If you choose a kind of rich superset metadata model as the canonical standard, then you only have to write n converters, which is a great saving. So an element set has been proposed and has been discussed at length at plenaries and between plenaries. The main points are these. We're talking about elements, not attributes. That means things that have an internal structure, syntax, and also semantics, and they are not like columns on a punch card or columns in a spreadsheet. This internal structure is normally a set of attributes with any appropriate sub-attributes. So for example, the element description can include, for example, title and abstract, but maybe other things. Similarly, the element spatial coordinates can include not only what you'd expect, easting, northing, and altitude, but also the precisions associated with those coordinates. So what this implies, and this links with the FAIR I3 recommendation, is that there are relationships between and within the elements in the metadata, and indeed between the metadata and the assets being described. So we end up with things like originator person is author of the related publication, optionally with the date range over which this assertion is true. So is author of is actually the semantic relationship between the two entities or objects being described, i.e. the person and the publication. What we end up with, of course, is then a fully connected graph between and within the elements, which gives rich structure, rich syntax, and also rich semantics, which is denoted on the edges between the vertices. So here's the element set as it is at the moment. This is over 2 slides. So unique ID, location, as in where the asset is, description, keywords, temporal coordinates, spatial coordinates, originator, project. And you'll note with each of them, there's a bit.ly URL. And these point to Google Docs, where all the discussion and ideas about these element sets that has been recorded, I'm sure there's been discussions that haven't been recorded, this is where you can find them. And the second page of elements include facility or equipment or both, quality, availability, which covers licensing, but also persistence and associated curation, provenance, huge area in itself, citations, related publications, related software, schema, and medium or format or both. So that's the proposed set. Some overall remarks. We're still lacking detail despite a lot of work, and there's more work to be done. Some characteristics are emerging. Definitely people are appreciating the idea that we should have relationships between and within elements. So metadata to form a rich metadata set to which we can convert for interoperation needs to have this richness of syntax with associated semantics. And that leads me to the fact that we need classification on many elements. First of all, for properties of the entity, e.g. for a medium. So for medium, we need a defined list of acceptable terms, a classification with relationships to other terms, and indeed, especially for multilinguality. And similarly, we need a classification for the roles in the relationships of the entity with others, e.g. the relationship between a data set and the owner, where the role, owner, which is likely to be a person or an organization, that role needs to be in a defined set of terms, again, ideally with subterms, superterms, related terms, and multilinguality. So this is an appeal. Please comment in the Google Docs with your ideas about the element set, because the more people who are involved in getting it right, the better it's going to be. Thank you.
Thank you, Keith. Are there any questions for Keith? Okay, then let's move on to our next presentation from Steve.
Alrighty.
And you should be able to share your screen.
Yep. So I've got, I'll make sure I'm on the right screen to begin with. Here we go. And I'll shift presentation mode, I think. Okay, how's that coming through?
That's good.
Excellent. Good. Got it. Yep. Excellent. So I'm going to give a bit of a quick tour of sort of metadata in the social sciences and what the emphasis has been. I'll put my hats on early on. So I'm director of the Australian Data Archive based at ANU, but I'm also the director, the chair of the executive board of the DDI Alliance. So I'm going to focus quite a bit on the data documentation initiative, which is probably the dominant metadata standard in the social sciences, but I'll touch on other spaces there as well. So the point here is to sort of give a bit of a walking tour through kind of what are the frames of metadata standards that tend to get used, and I'll focus on what DDI specifically has been doing, and then I'm hoping in the discussion we can talk to some of the questions around where the overlap might be. I can see fairly early on that that's the case, but perhaps look into that in a bit more detail, I think, in the discussion. Okay, so in the social sciences, we tend to see if I was to sort of classify them, so the use of quite a number of generic metadata standards, Dublin Core being the simplest of those, DCAT, really sitting now with the W3C, and increasingly schema.org is one of the frameworks that's tend to get used there. But we have for a number of years certainly been developing specific metadata standards for use within the social sciences that we're increasingly seeing are applicable across the sciences. So that was the one I'm most involved with, the data documentation initiative, which I'll talk to in some detail. Tends to focus more on tabular quantitative data formats and methodologies related to the social sciences, humanities, some of the population health sciences and the like. In recent years, we've seen things like REFI-QDA, which is for what we would call in the social sciences qualitative data analysis. Realistically, this is a means for using analytical methods to analyze and import text, audio, video, and other images. So it's partly about the metadata around those data formats, but particularly around how you describe the analysis techniques, coding techniques, and the like. And it starts to bleed a little bit into things like text encoding, into text analysis. Some of the text extraction techniques that you start seeing machine learning if you sort of head down that track. A third that's particularly common in the linguistics and domains and some of the qualitative and humanities areas is the text encoding initiative, TEI, and it's often got its own flavors as well. And then quite a heavy use then also of what I might describe as cross-domain standards, particularly the geospatial standard, ISO 19115. Social sciences are heavily interested in geography and geospatial patterns, so that's probably the most prominent one, but there would be others there as well. And you could probably classify those into generic case, but I think in the case of the social sciences, we sort of see spatial as it's a cross-domain question, but the content of the spatial information is important to understanding the research problems we're dealing with as well. Okay, so I'm going to focus on DDI because that's probably got the broadest usage across the social science, certainly across the data archives, and I'll touch on a couple of the major programs that are there to sort of give you a sense of where this is used. It's an international standard for describing particularly data coming out of surveys and observational methods in social, behavioural, economic, and particularly population health sciences. And we're using a number of domains there. It's open and free and is designed to cover different stages of the research data life cycle. So we have increasingly extended our efforts to support different stages in the research life cycle. And it's interesting to take a sort of a dimension on the metadata discussion that Keith presented to think about what do you need at different stages in the research process. Is another way of framing that, I think. So DDI, as it's evolved, has started thinking about that. So I want to give you a bit of a sense of what's in the DDI product range, as it were. We describe the outputs of the Alliance as work products. So there are a number of specifications, quite a number of controlled vocabularies. Some of those expressed additionally as RDF vocabularies, and then a suite of developing products. And I'll touch particularly on the one that we've been working on in conjunction with CoData recently, the DDI cross-domain interoperability standard, which again might have some relevance here. So in terms of the current products, DDI has been around. The first release was in around about 2001. The DDI codebook. It's really described for describing a single study and for describing codebooks or data dictionaries. So how do I describe the elements in a data set, their content, location, and it's to take the metadata framing that Keith provided. It's really about describing partly projects, partly authors or originators, but specifically, and I think this is an area that probably isn't picked up in the metadata sets that we saw, is around the content of those tabular data sets, so variables, what's in the columns and rows fundamentally. But it's designed for a single study and to handle them in isolation. The extension of that, the DDI lifecycle product, came a bit later on. I think it was around about 2007. Both of these are XML based specifications. This tried to then start going, well, what if you have content that works across data sets or collections? So several ways of data collection, or even ad hoc collections of data sets for the purposes of comparison. So studies following people over time, what we might call cohort or longitudinal studies, tends to get used increasingly in statistical offices, larger research projects, particularly long-term research projects. And then we have a couple of the other areas, which I'll touch on in a moment, that are not current products specific metadata specifications. These are tying into the vocabulary services. For the specifications themselves in XML, and I put links throughout the document, you can find the details of those specifications. The control vocabularies that that DDI has are terms and definitions for things like particularly around describing collections, describing methods, and the like. So there's a series of them. Oh.
I don't know how to open the door to let the dog out.
Oh, okay. Just a minute, please.
Oh.
Sorry, folks. So our terms and definitions are things like, as I say, methodologies and the like, and increasingly they're being hosted through international collaborations. We make them available as XML, HTML, XLS, but vocabulary services, and particularly the CESDA vocabulary service. So CESDA is the Consortium of European Social Science Data Archives. It's is free infrastructure in Europe, and there's a couple of representatives of that organisation on the call as well. Ron Decker, who unfortunately can't be here, is the lead on the CESDA program. But it's a vocabulary service and makes it through SCOS and other services, and through API access as well. Then we extend, some of these vocabularies have been extended into RDF vocabularies. Probably the one that might be of some interest is the XCOS RDF vocabulary, which has taken SCOS and extended it to be able to manage statistical classifications. So national and international classifications for describing all sorts of content. So occupational classification, the industry classification and the like, to be able to represent, the semantics of some of those relationships. Again, touching on some of the issues that Keith raised. We have a vocabulary called DISCO, which is for discovery metadata, taking a subset of the DDI collection to support discovery through linked open data principles. We also had a third RDF vocabulary in development, the physical data description, but we put that on hold because in work we've done in collaboration with folks often working with W3C and other linked open data groups, we found that that things like CSV on the web were probably going to overtake that, and we've invested our efforts in looking at how we connect into those instead. The more recent one, the development we've been doing though is in what we call the CDI, the cross-domain integration, which was originally intended to be our next wave. So Codebook led to Lifecycle, and then progressively to, we were thinking CDI was the next thing. But what we actually found that we've developed as a companion instead to better look at how we support data integration, machines, machine actionable data integration as well. So this is really tying in on the interoperable element of FAIR. The other product that we have in development is a language around data transformations that's come out of the BioCaddy project and the C2 metadata project, particularly run by a colleague, George Alter, who's at the University of Michigan. And we've been picking up support for that to represent data transformations in abstracted from the analysis packages, so you can describe transformations effectively. Independent of the environment that you're working in, the language you're working in. So just quickly on CDI, we were looking what's its goals and its purpose. really to try and pick up the space that isn't there. And I've kind of touched upon here, be able to represent variables and the interactions between variables more effectively, concepts, and also be able to follow and understand and track datum with a datum, or if you think about it, datums, data. So be able to look at the provenance elements required to actually follow changes in data over time, or datums over time is the language you actually found easier to use. It covers data formats. You say it's current. Well, we've just completed the first public review, and I put the links here in the slides. And we're currently reviewing the responses to that. It describes data formats, process and provenance, and some foundational metadata, codes, classifications, concepts, variables, and the like. It doesn't extend into some of the content that we've talked about in the metadata element set, partly because a lot of that exists in the DDI codebook and lifecycle, the higher levels of those frameworks. The next stage of work is really to look at some of the connections into there, and that might be a basis of discussion here too. It is intended to be cross-disciplinary as well, particularly to focus on things like variables and classifications, and be complementary to some of those domain-specific models to allow you to understand and exchange data between environments is really the emphasis that's here. And I'll leave that at that. Just a short summary there.
Are there any questions for Steve? Okay, so what we've been doing in this plenary, as well as previous ones, is reaching out to other different domains. And this was the first time that we connected with the social sciences. So the next one is actually a little bit different in connecting with the project. So Larry, would you talk about DISCO, not to be confused with the DISCO on the in Steve's slides?
Right. This is the DISCO with 2 S's.
Okay.
So I'll share my screen. Okay, and go into presentation mode. Okay, so I'm Larry Lanham, CNRI. But in this session, and I'll be fairly brief, I'm representing DISCO, which is the Distributed Systems of Scientific Collections. I'll show you what it means in a second. Probably most of you have heard of it. Most of the slides are from Alex Hardesty, who is with DISCO. The reason I'm doing this is because, number one, I was available, and number two, I am on the technical advisory board of DISCO. So there you have it, Distributed System of Scientific Collections, very colorful bugs. This is, you'll see the DISCO slides, big difference between the DISCO slides and my slides. This is a DISCO slide. The next slide is black text on a white background. That would be my slide. But I'll start trying to describe it. And also on the call is the guy I think of as the director of the DISCO project. I think he is Dimitri Kurias, so he can jump in here and correct anything I say. But I've done this for other audiences before. This one slide, maybe the next one as well, which is what is the challenge that they have here? This is an attempt to be flip about it, to make a global museum of specimens. It's currently widely distributed across all sorts of institutions, and digital information is held in widely variant and largely disconnected systems. The physical access, of course, is expensive and slow compared to what we're used to now in terms of digitization of things. And there's very little connection of the specimens to the associated data, qualified or not. It's just not there. The result is a significant underutilization of an enormously important existing set of resources. They're growing in importance, which is one of the reasons I find it to be an interesting project. And of course, we recently had a dramatic illustration of that in the jump of a virus from animal to human. And there was a fair amount of scrambling around to try and try and figure some of that out, information that would have been available in a better networked set of information in biodiversity. So that brought out DISCO, which is an EU effort to put all the natural science assets under a common curation and access policies, make that one giant collection that's more accessible. According to FAIR, it's big, 1.5 billion specimens. It's 120 collaborating institutions. So just on the basis of bureaucratic organization, it's an impressive project, to me anyway. 5,000 scientists, 21 countries, and the DISCO Prepare phase of the project started earlier this year. That's 3 years and 31 partners to do, as it says here, deliver organizational, financial, and technical guiding framework for the construction of the infrastructure. So they're in effect building the museum before they populate it. That's what goes on for the next 3 years. Now the next set of slides, again, we're back to colorful slide land, which means they're not mine. This is the minimal information standards for each of these specimens in 3 different levels, MIDS, 1, 2, and 3. 1 is basic record of specimen information. If it was, the 19th century, you could envision that as the index card with Darwin handwriting what this is, where he found it. The next extension out from that is key fields, and the one after that is extended, which we'll talk about. The prominent feature there is beginning to build this knowledge graph across all the specimens. So we'll look at each of these individually, but it's important to note in the context of this meeting that these are not static at any point. They're always added information can always come in, annotations, further curation decisions, and so on. The general context here is that the specimen data will be made accessible in association with a persistent identifier so that you can reference it. There is also a 0 level, which would be the first association between an identifier and its digital representation, perhaps barely before it exists. You might think of that in the field, for example. All right, here's a little detail on MIDS level 1. These should be all fairly self-explanatory. The columns, which I can't quite see because of the Zoom stuff, which I will move. There they are. Is Darwin core, a take on Dublin core, ABCD, which is access to biological collection data, and then the comments there, recommendations is the last one. So created on, record creator, the value of what level this record is at, physical specimen identifier, and so on. Name is qualified by one of the later elements. So when I look at this list, and when I look at the metadata interest group list of elements, I can see that there would be places to inject these, match them, map them. I can say that ahead of time for everything, as far as I could tell from my brief look at the set of elements. The more interesting questions to me is how and when that mapping takes place, whether it's dynamic or static, and the fact that remember in the previous slide, these records are in motion. They will change over time. Let's look at level 2, which is more interesting. Why did that happen? I don't know. Okay. Here we get a lot more detail. Here again, I assume there's ways to map these, but at a lower level of granularity, and they would need some understood context. You think about the altitude, depth, if known. I know that there are elements in there that would accommodate that, elements in the combined metadata interest group set of elements. But this would be a specific, kind of altitude or depth. And there might be nuances, I suppose, in collections where that sort of thing has a specific nuance in a specific kind of specimen. Name identifier there's a small error in the slide. That's actually name element 8 on the previous slide, which is the kind of name it is. Okay, now MIDS level 3, quality assertions, and I see that's one of the MIG elements, format structure to be specified. I didn't follow it in the bit.ly link, but that's come up in a number of discussions I've had this week about how you qualify quality. And then the important one, external link information. The following 5 fields repeated. This is how you build up the graph. That is the real point of all of this, is to have all this data available and connected. And here are the connections, the links between the nodes. Level 0 is essentially an empty catalog record. So that would be the start in some cases. And the final slide, where is it? I mean, this is, I suppose I should have introduced this differently, and Dimitri can certainly comment on it. This is a moving target. This is not, I don't know the level to which this is decided, but this is being tried out. It probably will move around somewhat. So they'll prototype it. It will be, some guidelines will be added, and there's a TADWIG working group being proposed. Dimitri, did you have any comments on all of that?
Thanks, Larry. No, no comments for now. I think I'm always impressed from the simplicity through which you present those things. I wish I could do the same.
Okay.
So,
okay, well, thanks.
So no comments from me, and I can jump in questions if there are any.
Okay, so but I have a question for Keith or Rebecca. So is this what you were looking for? How would this proceed? That is a large project like Disco, you would ask that project to help in doing the mapping, or you would try and get them to, I guess I should say us in that case, but I'm in a different part of Disco, so I'm not the domain guy. How would you go forward with a project like Disco if it's 120 institutions and 5,000 scientists and this kind of level of detail? What would be next?
It's a good question, and you have officially started off the next item on the agenda that Alex is going to
Okay. In that
take
case,
care of. So we'll let Alex start out.
Okay, I will stop sharing.
Well, thank you very much. As Rebecca says, that is a very good question. And looking at the spreadsheet that you just presented there, that looks like it will be a very valuable resource for us for progressing our unpacking of our element set. It goes into quite granular detail on some of our elements, and so that will be a good thing for us to be able to specify the syntax in those elements. And what I particularly liked is that you've done a similar kind of thing that we were also hoping to do, is to test our unpacking and test its sort of status as a superset by actually looking at metadata standards in the wild and doing the comparison and seeing if we can represent those elements using our element set. And so you've done something very similar there with a Darwin core and ABCD. And that would be a head start for us as well. Once we've incorporated the MIDS elements within our unpacked structure, then we've immediately got some mappings there to give us a head start. So that looks really helpful. I would welcome more comments from other groups, and we would certainly like the Disco project, to contribute to our element set and it might just be indirectly by the way that MIDS is developing, and we keep an eye on that. But also, direct input would also be valued. I've been speaking a lot this week, and what we really want here is to hear the experiences from RDA, from all you guys out there, and specifically to give us for the course of this session, the kind of social science aspect. So I'd like to invite people to raise hands. Steve, please come in.
Yeah, so I sort of raised my hand because I didn't do a sort of a one-to-one review of what's in the metadata element set there, because I can see quite a lot of what's discussed there is, I don't think that would be particularly challenging to map what's there. There's one glaring omission to me, and maybe it's because I'm taking the wrong angle on this, is there's not really any reference to data in its like that I can, what am I missing there? And I say this specifically because, I can see, in the last discussion, talking to a physical data, specimen, there's kind of a one-to-one relationship there as well. But for part of where DDI went in parts of its standard is being able to, and I sort of reference the cross-domain interoperability part of this, is describing what's inside data sets. Now that may or may not be a domain specific thing. We've tried not to be, but the big question we've had in work we've done with CoData and others, and Rebecca was involved a couple of years ago in looking at some of what's there too, is the interoperability part of FAIR is highly problematic because of how do you describe what's inside an object. So I'm curious to see where do I find that, but B, is that an emphasis of the working group as well, or the interest group as well?
Well, we want to be able to represent as broad as an amount of metadata content as we can, and there are metadata schemes that do delve into the detail of the structure of the data and actually try to describe that. DDI is one of them. There's a tabular data package standard from Open Knowledge Foundation. So these are things that are within scope for us. And so I think we've been grouping these so far under the broad heading of schema. But again, this is
okay.
For several of these elements, the name that we give them is sometimes not representative of the scope that we're imagining for them. But yeah, these are the kinds of things that we go under schema.
Okay, so yeah, I can delve into there a bit more and have a look. I think that because it's say let's say the DDI codebook, the parts of what you're describing, the metadata elements, the codebook part, fundamentally a big chunk of that is the sorts of things that are being covered here. So I don't see too much challenge in actually being able to align what's already there with what's in the elements here. It's really just thinking through what's some of the richness of the data itself. How do we get to that? That's that's of interest.
Absolutely. Has anybody else got some comments to make?
I actually have a question for the Disco project. Because things can be updated, how do you track what was there before things are updated? In particular, like scientific names have a way of changing and then changing back and then changing again. Do you track all those changes?
Well, Dimitri can answer what's going on now, which I think is probably the answer there is probably varied. And for the next part, what would Disco plan to do? That's part of the 3-year project. But yeah, the idea would be to track it fairly closely as the object changes. You would record the changes and be able to. That's going to be on the agenda. How do you reference things that have changed since the last time you looked at them, a la the RDA dynamic citation group.
Okay.
Yeah, just to add on that, Rebecca. This is a major requirement basically on how we want that digital specimen to represent a mutable object that changes all the time, and that's part of the idea of allowing a community curation to be done on top of that digital specimen that always represents the latest knowledge that we have about that physical object in cyberspace. And of course, one of the major requirements is also to be able to reconstruct any previous versions. And of course, the concept of version is very fluid here. Maybe take it a bit sensu lato. But be able to reconstruct any previous versions of that object and how we do that is still under discussion. There are multiple ways through which you can approach this, you can tackle this, and some of them you have to be mindful of the limitation resources, also in specifications for user requirements in terms of ability to reconstruct that version quickly. User needs, user cases would dictate also the frequency in which you can restore some of these versions, or even the ability to dynamically reconstruct any previous version of that object by employing other kind of technologies. We are also exploring concepts that are similar to blockchains, basically to be able to reconstruct any version of that through transactions performed of that object in the past. But that's a very big discussion, and we're definitely looking into this now and in the future.
So once the start phase is over, is there going to be an automated way for the existing collections to automatically be added or referenced by Disco?
Yeah, most of the collections already use what we call collection management systems, in which they maintain registries of their collections using either internal or in some cases community standards, data and metadata standards. Currently, most of those collections expose that information through Darwin Core archives files, and we expect to be able to use those Darwin Core files basically to start populating the central registry of digital specimens. But of course, the important thing for me here is the fact that this is not an attempt to just take things out of the museums into this new virtual museum. This is more about the need to move the process of the curation out of the geographical boundaries that currently exist in terms of physical access into that virtual common space, where basically we can pool expertise to start curating that information in a more community-based model. So basically the authoritative version this physical object moves away from the single institution, and is now located as a common property across the community. And this is a shift, a completely paradigm shift for all the way we've been operating for the last 500 years, some of us, as museums. So it's a big ask, but also it's required if we want to really deliver that kind of transformation that Larry was talking about before.
One way to think about this, which I started telling myself the story recently, I don't know, I don't think Dimitri's heard this yet, is that the physical artifact becomes an attribute of the digital object, which is that's an extremely important attribute. It's the source of it probably, and it's the prime attribute, but it's just another attribute. It's in that sense similar to a DNA sequence in some other database, or a bunch of articles published about it. But you begin to centralize the information on the widely accessible and shared object that lives in space.
Okay, that's interesting. Questions from anybody else? Alex, did you see the one in the chat from Sarah?
No.
Is there any discussion around information to related Indigenous people, knowledge names in the Natural Science Project? European collections hold a lot of material related to countries with Indigenous populations.
If you don't mind, I'll take this one. Absolutely. I think it's, we're not only talking about, of course, Indigenous people knowledge, and we're talking about all this concept of repatriation of all that information that was, if we were to be honest between us, most of our collections in Europe were developed based on practices that we're not very proud today of. So I think part of this process is how we open up that fantastic asset to the world, and basically repatriate that information back to the people that derived from. And it has to do with many existing policies in the world and practices and good practices. But the truth is that the only meaningful mechanism through which we can share the benefits of those collections today is by sharing the benefits of the information that is derived by those collections. And that's what we're trying to do.
Okay, so thank you for that. Alex or Keith, could you respond to Steve's comment about rows and columns not being included in the metadata elements? He said that during his presentation.
Oh, well, that was the point what we were making just now about
Data?
The schema element being the kind of umbrella for just talking about how the data has been structured. So very much talking about the columns and the rows, the variables, which variables are controlled, which ones are the ones that are being observed, those kinds of things. How data has been encoded. So if you are using your the coding scheme for, say, a person's occupation, then the metadata element that you would use to describe that. So that would all fit under the schema high level element.
Yeah, I looked at that one. It's not unpacked yet, and
No.
I can see why. But that, looking at DDI might give us some ideas too.
Definitely.
So can I just pick up on that a little bit more, which is, so that I guess the other question I had was, look at this, was that the elements set as they stand also seems to me to talk about I'll use the word collection because I say I can't come up with a different word right now. A data set or something along those lines. That, and it depends on how you actually then go about using this set of elements that are in here. But certainly what we've learned as we've gone through is the other parts of this start becoming, there's a lot of repetition inside them as well. And this is probably the distinction between our code book and life cycle. For want of a better example, it's not perfect here, but so the case that, what was the equipment that was used that produced that specific file for that specific, there's a lot of, it's a graph of some sorts, but how do you fit the graph together, and what level of, thinking you're actually talking about there, it becomes, is a little bit challenging because, as I say, I've got 10 files that make up a collection, for example, which come from, maybe 5 different people with, number of different populations that are the emphasis of them. The way I use those elements is, I can move up and down the chain to describe the collection as a whole or its constituent parts. And I can see, where we've hit some, where Codebook hit its limits, for example, was not being able to talk about the constituent parts. You were only describing one thing in the end, and the files within that thing. How do we move up and down the, what are generally complex projects or complex objects that we're going to be describing here? That interrelationship to me, it'd be good to talk about how you play that out within the element set that we have here. How do I use that effectively to work at those multiple levels?
That is a point that I've been coming up against a lot, looking at the elements, and I look at the two elements that we have for related publications and related software, and I think that we either need more of those, or we need to more likely think about this more generally in terms of relationships to other resources. And if we did that, then we could start thinking about not only publications and software, but also the relationships between the data and the samples or the artifacts or the specimens from which data has been derived. We could then start delving into the structure, different levels of granularity to say this is, it's related to another, what you might call a smaller data set, which is a part of it, or you might think, you'll be able to relate it to pre-existing data from which this has been derived by combination and merging. I think we have kind of limited ourselves a bit there with those two elements, and we need to be thinking about it more broadly and with greater flexibility.
Although, if I can jump in, of course, if you consider the whole element set, imagine it as a complex record, then of course it can be related to another complex record. So you could have one, for example, data set related to another, or one data set related to part of itself, down to the level of an individual record within the data set, which may represent, for example, a sample. So by relationships between the metadata records, one can achieve that. Yeah. But yes, it's an area. I mean, we specifically added related publications and related software because these were things specifically asked for by the community, because they were things that were commonly required. And there's always a problem getting the right level. If you go too abstract, you can be completely general, and that's great, but then people don't understand what they're expected to put in each of the elements. And if you go too specific, then it makes it more difficult to achieve interoperability and generality that you would achieve at the more abstract level. So there's this balance of levels, and I find that particularly challenging.
Yeah, and I think that you can see that reflected in some of the words that we've used for these elements. I mean, we've used things like spatial coordinates and temporal coordinates so that people have a clear idea as the kind of things that we're talking about. But when we're unpacking it, we're thinking about it considerably more broadly than that. And actually, the spatial coordinates and temporal coordinates things would actually make more sense at a finer level of granularity. And I think, you know, we need something a bit broader at the top. So I think this is perhaps a symptom of the fact that we have come up with these as just high-level elements that hadn't been unpacked. I think it would make more sense to people once they have been unpacked and you can see the structure and that you have the several different layers of granularity there, and you can then start to see how different pieces of information slot into it.
Yeah, I mean, that granular is the right term for this. I think that, and Bob has sort of picked that up in the chat too, which is, yeah, these are less granular at this point in time, and that for the purposes of, that's why I highlighted a little bit the, where are you in the research process, and here as well, because for findability purposes as opposed to interoperability purposes, this is probably better actually. Less granular is better for findability, but less, but not so good for interoperability. So, how the application of these in different sort of circumstances is problematic in itself as well. But the spatial coordinates is a good example, as you say. Here's a person on a map, as opposed to here is the bounding box for a collection. Both of those spatial coordinates with different sorts of things. So.
We've also found out that by using the higher level, when I sent out a survey to find out which elements to unpack first, which one had the highest priorities, immediately received feedback of, oh, you haven't included title, you haven't included this and that, because they didn't realize which of the elements those would have unpacked, where those would reside. And so I think in some ways we cause our own confusion too by not, so we actually unpack descriptions so that we could address that. But you're right, it's hard figuring out what to name things at that high level so that people understand is not as easy as we thought.
So can I ask where you're heading next? Say, I mean, because that sort of question, sorry, that allows us to think a little bit about how do we can, get involved at that point. Where is the group heading that, and that would give us some direction as to where we might contribute, as it were.
The eventual end goal for this is, we want to be able to use the metadata element set really for two different things. First of all, as a kind of recommendation to the community. So for domains that are thinking about setting up new metadata schemes, to give them advice on key elements to include and some of the key principles of how to do it. So some of the things that Keith was mentioning about being careful to distinguish things that are attributes of an entity and things that are relationships between entities. The other major thing that we want to do with it is to use the metadata element set to analyze existing metadata schemes and kind of impose that kind of linked data approach on arbitrary metadata schemes, even if they haven't been written in a kind of RDF friendly way, so that we can relate the elements in them to the metadata element set and thereby use that as a Rosetta Stone for translating between them. And yeah, the eventual long-term aim of this is to have the a metadata element set translation of each metadata scheme in the metadata standards catalog, and then be able to write a script that will be able to create automatically generate converters between arbitrary metadata standards on the fly, as it were. So it would at least give a first pass at that. It might need to be refined for a particular use case and to get some of the mappings exactly right later on, but at least be a good starting point. And that's what Keith was saying about trying to reduce this problem of n times n-1 converters to just thinking about n.
So you see, we're nothing if not ambitious. No, seriously, it can be done. I mean, in the work I do, I have a fair amount of experience of converting different metadata element sets or metadata standards from one to another. One of the major projects I'm on at the moment, we have 17 different metadata standards being used, and we're using a rich metadata standard as the switchboard, if you like, between them all. And the way we've done it with each one is very simple. You use a spreadsheet. You lay out the schema effectively of the metadata standard on the spreadsheet, compare it with the schema of the richest metadata schema you have, and map how you would convert from one to the other. And it's not difficult conceptually, but all sorts of interesting problems come out along the way. But nonetheless, it can be done. And then, of course, comes the hard work, as Alex said, which is writing the converters or getting the converters generated automatically by a mechanism comparing effectively the two tables you have, the specification of each metadata standard and the one you're using as the interconversion standard. But it can be done. So one way we could move forward, if various groups are willing, is to have one or more people from, let us say, the DDI team working together with one or two people from the MIG team, and just see how easy it is to map DDI to the element set. And that, I'm sure, will throw up lots of interesting questions, both for the metadata element set, but also for DDI. By the way, I'm using DDI just because you're here. I mean, the same is true of Disco, the same is true of the people working on agricultural standards, and the same is true of the space scientists, and so on and so forth.
Yeah, and I was wondering that, is that sort of the next direction, as you say, is like you've got a good starting point here for then to be mapping into. Now's the time to start, when you start mapping the schemas against it, what do you find? You seem to be at that sort of level now. That'll expose, what's still to come with on both sides. As I say, we know what we have a good experience of what DDI can't do, which is kind of has driven our development, and that would inform that as well, I think. But similarly, what's not there, what in the element set, and maybe what doesn't even, possibly shouldn't even be there. As you say, how do you limit? What's the extent of the scope? Fundamentally, I think is the question that will come up there too. So, yeah, I mean, certainly I have a spreadsheet, which has done this for, for several of the schemas that we work with, and a number of which I mentioned on the presentation there. Curiously, a lot of Dublin core sits in a lot of the middle of them, which gives you a good starting point as well. But it's got its own limitations, and how do we map then to what's in here?
Yeah, that's good. Thanks very much, Steve. I think that's right. Larry or Dimitri, do you think it would be interesting to do something like that?
Yeah, Keith, I'm very intrigued every time I hear you're presenting as well. I mean, I always take notes. It's like a school for me every time. But I was thinking of what you said before about the Herculean task of basically trying to convert everything into everything, or at least do this mapping exercise, which obviously is extremely difficult. But on the other side, I was thinking that maybe we should really also consider when it is necessary for that conversion or that matching mapping exercise to be done. And I think usually that is driven by specific use cases where that kind of requirement is in place. And I think this is, you know, I'm also coming from with my other hat on as a co-chair of the group that is working with the different communities of practice, basically the disciplinary groups within RDA, and where we were discussing exactly the same thing: how you gradually build a corpus of interchangeable, basically metadata standards based on the expressed needs that different communities have put on the table. And then the question is how, of course, you capture that mapping exercise and provide it to the rest of the world as a common resource. In the same way, today you can, you know, easily convert one file type into another. And of course, no conversion is lossless in one sense. So you always have to accept that loss, either in granularity or in findability or in any other dimension. But of course, in this process, you always need to know why you're doing it. What do you expect to get out, and what is the end target? So of course, I'm very intrigued, and I think many people in Discord would be very interested to follow this through. But the question is, do you think that this needs to be a user-driven, or sorry, case-driven process through which we develop this corpus of successful exercises of mapping metadata profiles or standards as a mechanism through which we develop further this world?
Sorry, Dimitri, for me, you were breaking up a bit then. I suspect it's me. I'm currently in Greece, actually. So can you repeat the last bit of your statement?
No, it was just a question. I was wondering, I don't know how much of my what I said you followed, but basically I was wondering, what do you think is the best way through which we can gradually develop this kind of successful mapping exercises? Is it a case-driven process? Is it more of a, you know, follow the opportunity process? How do you see this gradually being built? How do you select those different couple of metadata standards or profiles that you need to gradually start interlinking somehow?
Okay, got it. Yeah, I think there are several different ways of doing it. You can either be very practical and say, do this sort of exercise where people on both sides, as it were, are willing and interested. The second way is to say, what are the most challenging scientific problems of the day and that are to do with interoperation, and can we pull together the communities involved around the metadata standards associated with that? So either approach will work. The former requires enthusiasm from people. The latter normally requires some funded project to encourage it along.
Yeah, thanks.
I think the comment that Bob Hainish put in the chat earlier is relevant here, which is, depends what kind of interoperability you're after. So you can have coarser grain for discovery and finer grain for more levels of interoperability. So you might be able to do something. You might be able to do something more universally, and then use demand driven to push it down a level.
Thank you, Larry. Yeah, we basically in astronomy, did this coarse grain stuff to find stuff, and then in a second tier, we would interrogate a data repository that claimed to hold data responsive to the first query in order to drill down more specifically, and then get back sufficient metadata to actually do interoperability, like overlaying images and spectra and things with their proper coordinate frames and so forth. So had we tried to embed all of the metadata needed for interoperability in the basic discovery query, it would have been really unwieldy.
Yes, I think we do need to consider multiple approaches in parallel to suit the use cases that people have.
Does anybody else have some comments that they wanted to make?
Well, I guess one of the things we could do is ask the community if they have examples where they have successfully managed to interoperate across multiple, or where multiple is 2 or more metadata schemas in order to interoperate data, information, or anything else they needed to interoperate. In other words, get some success user stories. I see Dimitri has already put one in the chat.
Okay. Thank you, Dimitri.
Can I ask actually to unpack that example a little bit more, because this kind of touches on where I was heading before, which is the objects that the different disciplines and domains deal with are quite varied. If I was looking at the MIDS example from before, I think the endpoint here is a specimen. Is that correct? The complexity of what you're trying to deal with at the endpoint of the metadata record is part and parcel of where some of the interoperability problems, I think, kind of have their issues, aside from what to describe. But the detail that you need at the endpoint there, is going to vary as well. Is that my correct interpretation there? That what I'm trying to do at the end of a MIDS record is here is a specimen, and I'm calling in that specimen. I'm trying to retrieve that information on that specific specimen.
Well, I guess for the MIDS specifically, the idea is more of an indicator of completeness of information that comes along with that virtual digital representation of the physical object. So basically, a way of describing it is the level of completeness of digitization of a specimen.
Oh, yeah.
But have digitization in a very wide, with a very wide definition, right? Don't just think about imaging, obviously. Yeah, that's the specific concept of that standard, or at least attempted standard. Yeah. But I think the example, actually the example I put is not correct. I should have started with ABCD Darwin core bioschemas.org, because basically that value chain also somehow shows from how you can start from a very granular metadata standard like ABCD and gradually start abstracting up into more generic metadata profiles like Darwin Core, like bioschemas, and of course from bioschemas to schemas.org. And I think that's an interesting pipeline that shows basically how you gradually can do this. But in the process of doing it, as you said, Steve, the reason why you do it is because you basically have different endpoints, you have different targets. And the higher you go in this, basically what you attempt is better discoverability, of course, better findability of your object. And the more you go towards the other way is being more scientifically driven about making sure that you convey up to, you know, as granularly as you can, all the different aspects, attributes of your object. You know, what you select and how you do it is not so important for me. What's important is that you have established these transactions between all of these profiles, and someone can easily move between them. Of course, you can only go upstream. You cannot go downstream. That's the problem. But yeah.
Yeah, I'm just trying to think through what that implies actually. As you say, you're sort of becoming less granular as you go to deliver into a service, and you take that back out again and then return the granularity. As long as you can trace the chain back to the ABCD record, for example. Yeah. You know, what that process potentially means. But I mean, just in terms of describing interoperability, I mean, some of the use case, you know, if we're thinking about how you actually use this, some of the use cases, it might be useful to think about what is that flow of information and what is actually that flow of usage, frankly. You know, in the end, the researcher wants to get the data to, you know, to plug into their algorithm, you know, whatever the case may be. But what's that flow going to be? And how far can you move along that chain tells us, I think, something about what, you know, how interoperable, you know, how successful you might be in that interoperability. You know, just might be a way of thinking through about, you know, how far you can get with that.
Does anyone have any more thoughts on this subject before we wrap up?
Thank you everyone for coming. And the recording will be available 24 hours later, and I'll put a link to it from our page that described this session. And I'll have the slides in the metadata interest group repository on the RDA site. And don't forget to go to the closing to hear all about P17.
Okay, thanks, Rebecca.
Which may or may not be virtual. Thanks, everybody.
Thank you.
Bye.
Thanks indeed. Very good session. Thank you, everybody, for your contributions.
Yeah, thanks all.